Okay, this video tutorial looks at the mathematical strand of patterns and algebra, and more specifically we're going to focus on the difference of two squares factorisation. Okay, now what you got to remember when you're factorising the difference of two squares is that with factorisation we are putting it back into brackets. Alright, so when we're starting with something that looks like this, and we're hopefully ending up with two sets of brackets next to it. Factorising the difference of two squares is very simple because all you need to do is know that your first term, in this particular case, is a squared. You just need to know that the square root of that term becomes your first terms in our brackets. And your second term here, which is b squared, the square root of that becomes your second term in each bracket. And then all you need to do is change the symbols. Alright, so remember your first terms of each bracket are just the square root of your original first term in the factorisation, and the second term in your brackets is just the square root of your second term. Alright, and then the only difference between the brackets is there's a plus in one and a minus in the other. What I mean by that is, we'll go through some examples and hopefully that'll make a bit more sense to you. So if we have a look at some examples here, well, we know that our first example, 4 take x squared, is actually 2 squared take x squared. Alright. Now the square root of 2 squared is 2, so the square root of 2 squared is equal to 2, and the square root of x squared is equal to x. Alright, so we know the first term in our brackets is going to be a 2, the second term in our brackets is going to be an x. So straight away we can go 2x, 2x, and then all we need to do once we've done that is put a plus and a minus, and it doesn't particularly matter which way it is. Here we know that 9x squared can become 3 squared x squared, and we're going to have take 4 squared. We know that if we square root 3 squared and x squared, we're actually square rooting 3x squared, so we'll put that in as our next step. Now we're going to find the square root of 3x all squared. Let's rewrite that. And take away the square root of 4 squared. Therefore our terms are going to be 3x and 4. Therefore we can write our brackets as 3x and 4, 3x and 4, and we just need to put a plus or a minus in, and we're done. Sometimes with your example questions you might have to take out a common factor first. So in our first example here we might take out the common factor of minus 2. That way we've got minus 2 outside of x squared take 4. Alright, now you can see that the x squared take 4 is actually the difference of two squares, because minus 2 become x squared take 2 squared, so it becomes x squared take 2 squared. Now we're taking the difference of two squares. We can see straight away that we're going to have an x and a 2 inside each bracket, and we just end up with a plus and a minus. In our second example, we might take out n squared as a common factor. So a common factor would be n squared. That would leave us with 64 take n squared. And straight away we can see that 64 is actually 8 squared take n squared. Therefore our factors, we're going to have n squared out the front, then we're going to have 8 and n, 8 and n, and we're going to have a positive and a negative. Alright, so take out the common factors if you need to, and then hopefully you'll be left with the difference of two squares to be able to factorise. Okay, so remember that when we are trying to factorise the difference of two squares, we need to make sure that we have our expression where we've got our first term squared minus our second term squared. And you can see that in our first example, we do have our first term to the power of 2, but our second term is not in the form to the power of 2. So what we need to do is we need to rewrite this as 2x plus 1 take 3 squared. Once we've done that, we've got our first term, which is our a, and our second term, which is our b. We can then rewrite this as 2x plus 1 take 3, plus 3, and 2x plus 1 take 3. That'll give us factorization of 2x plus 4 and 2x minus 2. Now we'll do something similar in our second example. You can see that we've already got our a term and our b term. Alright, so this will become 3x minus 1 plus x plus 1. Alright, and then our second bracket will be 3x minus 1 take x plus 1. This expands to 4x, and then the minus 1 and the plus 1 cancel each other out, so just 4x. And remember that this minus makes that a negative x and makes it a negative 1, so we end up with 2x take 2. Okay, so now I want you to have a go at some practice questions. Once you think you've got the answers, pause the video, have a go at them when they come up on the next slide, and then once you think you've got the answers, continue on to the last slide. So as stated, here are some practice questions I'd like you to have a go at. Once you think you've got the answers, we'll go through them on the last slide. Alright, so let's see how you went. In our first example, alright, our first term is an x and our second term is 16. Now remember, 16 can actually be rewritten as 4 squared. So now, if I write it like this, we've got our a and our b. So that basically means we're now going to have x plus 4, x take 4 as our factorization. In our second example, again, our second term needs to be rewritten. Alright, so we're going to rewrite, but our first term stays the same because that's already to a power squared. I'm going to change the 4 to 2 squared, x squared. We know through our index laws that this actually becomes x plus 3 all squared, take bracket 2x all squared. We now have our a and our b terms. That means that we can rewrite this using our formula, and we have x plus 3 plus 2x and x plus 3 take 2x. We then collect the like terms and we end up with 3x plus 3 and negative x plus 3. In our last example over here, the first thing we need to do is take out a common factor. So we've got a common factor of 3. I'm going to take that out and put it out the front. That leaves me with 4x squared take 9. Now we know that 4x squared from here can be rewritten. So I'm going to rewrite this as 3 outside of bracket 2x all squared, take away, and we know 9 can be rewritten as 3 squared. Therefore we've got our a term and our b term, and I'm going to rewrite this. I'm going to say 3 outside of 2x plus 3, bracket 2x take 3. So now we're going to have 3 outside of, we don't need to write anymore because it's done. And that's how we've solved it.